welcome to today's Spectrum Scale Expert Talk. I'm Bob Osterlund, one of the principals of the IBM Spectrum Scale user group, and I'd like to welcome you for today's discussion on the policy engine and lifecycle management. So if we could flip the charts ahead a couple of slides, we'll give a few introductions about that. A little bit about the user group. We're an independent user group. We work with IBM to help develop the events. We couldn't get these events online without their help. So thanks to all of IBM that helps along. As a user group, we're here to help foster discussions and help solve your problems and get questions answered. But we're not a replacement for an actual problem report to IBM. So if you join the email or the Slack community and want to have a question that needs answers or a critical problem, you really should be opening a PMR and getting it solved that way. But we'll help out wherever we can. If you're interested in participating in either the Slack or the email community, you can go to spectrumscale.org, and those instructions there on how to join either of those community. Everyone is welcome. So let's go to the next slide. And the principals right now of the user group, Simon Thompson, Christy Callback Rose, Bob Osterlund, and Bill Anderson. Christy and myself and Bill are for the USA. Simon takes care of the UK. We also have Chris Chapolius, that's part of the Australia user group. He typically doesn't join in on these US events because of the time difference. He also has events in more of an Australia or Southeast Asia friendly time zone. So next. And for all the Spectrum Scale expert talks that have been going on, this is number 7 in our series. There's charts, show notes. Most of the talks are also up on the YouTube channel. So if you want to go back and review any of these talks that have occurred in the past few months this year, check those out. The charts, I say, are widely available. After today's lifecycle management talk, we have 3 more scheduled. Another expert talk on multi-node scaling that's occurring in a couple of weeks. And then following that, we're going to actually be getting into the SC20 supercomputing sessions, the November 16th and 18th, in conjunction with the other supercomputing events. We're still nailing down the details of those sessions. There'll be some more expert talks and some opportunities for other discussion. So stay tuned, watch the Slack channel, watch the mailing list, and you'll get some more details about that. Next. And so with that, let me introduce Niels Haustein from the European Storage Competency Center. He's going to give a talk today about lifecycle management, policies, and all things related to that. He's responsible for the storage and design implementation for the file object storage. So I'll turn it over to Niels.
Thank you very much, Bob. And welcome to all attendees of this session. Thanks for joining. Before I start, I have to present this disclaimer, which you may already know if you have joined previous sessions, that talks about statements regarding plans and directions are subject to change, as well as, product specifications and offerings may change. So, but I'm not particularly talking about directions and plans and not offerings and products, but more about the techniques, of the Spectrum Scale ILM policy engine. Okay, so it is my plan for today. So I will give you an overview about ILM and policies and rules in Spectrum Scale, then, highlight the functionality of the Spectrum Scale policy engine, and then talk about particular, policies, you can configure in your system about placement policies, migration policies, list policies, and then I have another section with some hints and tips, how you can tune your policies and stuff like that, make it better, improve it. After each of these sections, I will stop for a moment, if there are questions which cannot be answered, in the Q&A, we can talk about that. We have a team of panelists available, which is monitoring the Q&A. So if you have questions, please use the Q&A. Ask a question in the Q&A. Our panelists try to answer the question in the Q&A. Please do not use the chat because we may not monitor it so often. Use the Q&A if you have questions. Okay, now this brings me to my first, real slide. About the Spectrum Scale ILM architecture. As you can see on the right-hand side, that's a view into a cluster, right? A cluster is a set of nodes, with storage attached, direct access or indirect access through an NSD server, And the key part of a Spectrum Scale cluster, of course, for the user is the file system, because this is where he can store data, right? The file system is composed of pools, okay? So the pools, storage pool is a collection of disk of the same type, right? And actually ILM, Information Lifecycle Management, is carried out on a pool level, or at least, migration and placement policies are carried out on a pool level. And you can use pools for many other policies, including deletion, compression, list policies, and so on. So the pools are implicitly formed from so-called NSDs, network shared disk, which are representations of the underlying storage lengths, And as you can see here, we have a pool on a storage system called Gold. Obviously it's a very fast flash storage system, and all lengths from this storage system are being grouped in a pool system. And we have another storage system called Silver. It may have SAS on the line, SAS disk, and all disks from these pools are grouped in pool Silver. Okay. Now, from a policy perspective, we have placement policies, So when the user stores data in the file system, somebody has to decide whether it's stored on the fast disk or on the slow disk, right? Well, the admin decides it, right? The admin creates placement policies which control where files are placed, and these policies are applied when the file is being created, okay? And then, of course, you have migration policies. If you have multiple pools in your setup, you will have migration policies, and they control the transparent migration of files from one pool to another, So a typical scenario is that you migrate data from your fast SSD-based storage, to a slower storage, if the data has been accessed for some time, right? So these migration policies are applied during the life cycle of the files, and from a user perspective, nothing really changes, right? I mean, the user still sees the file, for a large file, he may notice the difference between SSD and nearline SAS disk, but other than that, from a user perspective, the user can see the file and he can transparently access the file, even the file has been migrated to another pool, okay? And there is a notion of internal pool and external pools. I'm going to talk about this on the next slide, which is just, who serves the pool, right? So the internal pools are served by Spectrum Scale directly through the NSD devices. External pools are served by external applications. And around all that setup, we have the policy engine, okay? So the policy engine, is the machine, which essentially applies and executes these policies in a very efficient way, okay? And I will highlight a little bit how the policy engine works, and how it can be programmed with policies and with rules and policies. Okay, now in the file system, we have different storage pool types, internal pool and external pool. The key difference between internal pool and external pool really is, that you cannot place data on external pools. So when you program placement policies, you have to place on internal pool. And each internal pool must contain disk or LANs, disk devices or LANs with similar characteristic. Okay, so flash is one characteristic, nearline SAS disk is another characteristic, for example. In the file system, you always have one pool, which is the system, which is called system. This name is given, is predefined. And this in the system pool, also the file system metadata is stored. You can imagine the metadata being the inodes of the files and directories. The external pools, allow migration to external stores. The external pool, from a Spectrum Scale perspective, is represented by an interface script, that belongs to an application. Okay, applications, which provide interface scripts, for migration, or for example, IBM Spectrum Archive, IBM Spectrum Protect for space management, and Spectrum Scale itself has, interface scripts to connect to cloud object storage. And the external application is invoked, when the migration policy is executed by the policy engine. Okay. All pool names can be defined by the user except of the system pool. The system pool is always present, and that has a given name, which is named system. Okay, now what is the policy engine in Spectrum Scale? So the policy engine is a SQL interpreter that executes rules. Rules define selection criteria and action in an SQL-like language. And the rules are created by experts, right? The policy engine itself runs multi-threaded on multiple nodes. You as an admin have control, on which node it should run and not, There's one master node and multiple helper nodes that share all the work in all the phases, which I'm going to elaborate in a couple of slides from now. So the policy engine is essentially reads the metadata, from the inodes. It matches, the metadata properties of the files, or the metadata attributes of the files, against the selection criteria provided in the policy rules. And based on that selection, based on this matching, it selects candidates, and creates weighted lists. The weighting of the list can also be influenced by the admin who runs the policy, okay, or who executes the policy. So the policy engine is used to implement ILM. Okay, so ILM, essentially means to store the data on the most appropriate storage media over the lifetime of the data, right? So key techniques for ILM are placement, right? So the initial placement of a file is part of the ILM concept, and also the migration of files, right? So because once a file is being stored like 5 days on flash disk and it's not being accessed anymore, it may be possible to move it to a slower type of disk, which is less expensive, right? So one of the key goals of ILM is really cost saving by storing the data on the most appropriate storage media. Okay. Of course, deletion also contributes to cost savings, and compression as well, right? Because if you compress your data, you don't need as much storage capacity in your Spectrum Scale storage. Statistics are also important ILM concepts, because with statistics you can identify, where you have further potential to optimize your storage cost. Okay, and all these fields, all these techniques, placement, migration, deletion, and so on, are provided by Spectrum Scale. Okay. In fact, internal storage services of Spectrum Scale also rely on the policy engine. For example, AFM uses the policy engine, the backup function mmapplypolicy uses the policy engine, audit logging uses the policy engine, watch folder uses the policy engine, and so on. Okay, so yeah, the policy engine is kind of a central part in Spectrum Scale, which can be customized by the user for certain purposes or by the admin. Okay. Now, the next topic is a introduction to the Spectrum Scale policy engine. Already mentioned, the policy engine evaluates and applies rules. It does this by selecting the files based on the criteria defined in the rules and initiating an action, which is also defined by the rule. So the action can be a placement, migration, a listing, deletion, compression, encryption, and so on. Policy rules are provided in a policy file. In fact, a policy really is a set of rules. Okay, so a policy file includes one or more rules. Okay, and these rules describe the selection criteria in an SQL-like language and the action to be performed. Let's take a look at this example here. The action to be performed is a migrate from pool system to pool data, right? I mean, it's almost easy to read, right? And the selection criteria is for all files where the file size is greater than, I would say, this is 1 meg, okay? So this is the selection criteria, okay? So with this rule, the policy engine goes in, and selects all files, with a larger size, with a size larger than 1 meg on system pool, and migrates these files transparently to the pool data. Okay, and as mentioned before, it all works in parallel. Okay, so policy, invokes other nodes, helper nodes to carry out this job of migration. The policy engine can be invoked in 2 ways, essentially. One is the automated invocation of active policies. So there's a concept of active policy, and each file system can have, or each file system always has an active policy, right? You may not see it, but when you create a file system, Spectrum Scale also instantiates an active policy, okay? The active policy is automatically invoked based on the rule types and definitions which are contained in that active policy. Okay, so active ILM policy for a file system can include file placement. Okay, so all your placement rules are encoded in active policies. Okay, and also the threshold-based migration. So if you want to do a threshold-based migration, so if your system pool runs at 80% full, you can define that if this threshold of 80% is crossed, all data, maybe which is larger than 1 meg, is being migrated to the data pool. Okay, and you encode these these rules, store it in a file, and apply it for your file system. And once applied to your file system, this policy is active and always looks for file creation and placement, and looks for the pool occupation to do the migration. Another way to invoke the policy engine is manual, or using a scheduler. The scheduled policies or the manual policies from an ILM perspective typically include migration rules, and typically you select, files based on their attributes in a more granular way, like based on their size and or based on their age, the access time, the last access date, in general, the active migration policy, or the active policy, the active migration policy must be threshold based. If you don't give the active migration policy a threshold, GPFS doesn't allow you to apply it because it needs to know when it should invoke this migration policy. Okay, scheduled policies do not require a threshold. Okay, you can give it a threshold, but you don't have to. Okay, typically the selection criteria for the file is more advanced in scheduled policies. Now, starting the policy depends on the type of policy. An active policy, which includes placement and threshold-based migration rules, is applied for a file system, with this change policy command. Okay, so the syntax is pretty simple, with change policy, the file system name, and the policy file. Okay, there's always a -I flag for these policy commands, and if you do a -I test, you can test the syntax of your policy before you actually apply it and get an error. Okay, so that's a good hint. When you instantiate a threshold-based policies, for example, you have 2 pools, system and data, and you want to migrate system pool at 80%. When it hits 80%, you want to migrate files from the system pool to your data pool in order to free up space in your system pool. In order to achieve that, you also need to configure a callback. That comes on the next slide, or on a couple of slides. Okay. Scheduled policies for file systems are invoked by the admin or by a scheduler, which is programmed by the admin, and the command used for that is the mmapplypolicy command. And this, from an ILM perspective, it executes rules for migration. Okay, so the syntax is the mmapplypolicy command. For the file, the simple syntax is the mmapplypolicy command. For the file system, it can be the file system name, it can be the file system path, or it can be a subpath within the file system. It can be path within the file system. Here's your policy file, which includes your migration rule. And of course, we have the -i flag, the mmapplypolicy command, is actually also invoked from when you have an active policy, okay? So it's invoked by a callback, which interacts with an active policy, okay? The mmapplypolicy command essentially executes the rule provided in the policy file, and it distributes the task to a number of nodes, and each node you can also specify the number of threads you want to run by each node. So here's a syntax example of the mmapplypolicy command, and no, I don't go through all that, right? I have prepared a little table here, which gives you most of the options I have stepped into, which seem to be important. Okay, so let's take the -m option. The -m option specifies the number of threads, which are dispatched for a file management operation on each participating node. Okay, so if you do a migration, and for example, you do a migration to tape, right? And you have one node which has 3 tape drives attached, you can set -m to 3, right? And then you get an optimal performance on your tape drives because each thread will mount a tape drive or will mount a cartridge in a tape drive and write the data to the tape drive in a perfect world, right? Another option is the -b option. That's the bucket size, that defines the number of files each of these threads gets for processing. So when the policy engine identifies, selects the files, it puts it in file lists, and the size of these file lists is determined by the bucket size, okay? And here the thing is, if you have many small files to process, it's better to work with a higher bucket size, with a larger bucket size, maybe 1,000, maybe 10,000. If you have really large files, it may be good to have a smaller bucket size, maybe 10 or 100, because, the task, which gets this file list has a lot to do with large files, so why putting in 1,000 large files, so break it down a little bit more, to make it more efficient, Another important parameter, and I'm skipping some here, is the -n parameter, -N parameter. It defines the node names, which these are the nodes which are actually, executing the policy. So they do the file scanning and they do the file operations. Okay. Yeah, and then there are some other parameters like the -s and -g parameters. With this you can set directories to store local temporary files and global temporary files. Because I'm going to elaborate on the execution phases on the policy engine on the next slide. But the policy engine selects files and puts these files in a file list. So these are all the files which are matching the criteria, and then it's sorting these files based on other criteria. So it creates more file lists. So these file lists need to be stored somewhere. And each node creates local file lists, and there are global file lists. The local file list can be stored on a local directory defined by -s. The default I think is still temp here /tmp. The -g parameter defines a directory, a shared directory in the GPFS file system, which is accessible by all the nodes participating in the policy execution. And this is used for global temporary files. Okay. Meanwhile, in GPFS 5, GPFS creates if you don't worry about setting this parameter here to a particular value, GPFS creates a hidden directory in your file system rule. And I think it's called shared temp dir, or .shared temp dir. Okay. Yeah. Maybe one last word on single instance. Single instance is important for migration to slower storage media like tape or maybe object storage, depending where your object storage is located, whether you have to go through the internet to an IBM cloud or an Amazon cloud. The single instance enforces that only one instance of mmapplypolicy can run. And especially, I'm a tape guy. I used to work I still work a lot of with tape. It doesn't make sense, to start multiple threads, or to start more threads trying to put data on tape than you have tape drives, right? The threads have to wait, So single instance makes sure, that your 3 threads, you start here, for example, run until they completed the policy, right? And with single instance, you can assure that no other mmapplypolicy comes into your way, okay? Important for slow storage media, for the migration from an internal pool to from within internal pools, from your system pool to your data pool, for example, it doesn't matter so much. Okay, so here you can have overlapping policy runs, even though it doesn't get faster, but still, it doesn't hurt, while I think that, if you overload your tape drives, it can hurt. Okay, now let's come to the execution phase of the policy engine. So it's 3 phases. In the first phase, the policy engine selects files. It does this by reading the metadata for files of the specified file system, device, file set, or directory. Okay, so the file system device, the file set, or the directory is specified with the mmapplypolicy command. Okay, so it's the device name, the second parameter in the mmapplypolicy command. Okay, and so it reads the metadata for the data in scope, which is specified, right? The scope is specified by the device name, and then it selects all the files matching the policy rules. Okay, now let's take a simple rule. The rule says, all files larger than 1 meg. Okay, so the metadata includes the file size, and the policy engine is easily able to match from the inodes without actually doing a stat on a file, which files have a capacity larger than 1 meg. Okay, so all these files, are selected, and put in a temporary file, and once this is done, the policy engine goes into a scheduling phase, choosing a scheduling phase. It creates in this phase, it creates file lists with all or subsets of the selected files. Okay. The order of the files in these file lists can be controlled with certain options, like, for example, the choice algorithm, or you can use split files by their weight. That's a nice feature because you can split, the file list into based on their weight, and the weight parameter can be, for example, the last access date, right? And in this case, all files with the same last access date are in one file list, okay? An even better example is if your weight is a directory hash, then all files within the same directory are in the same list, again, very useful for tape-oriented migration. So these file lists, which are now being created based on this ordering and selecting of, and choosing of files, the size of these file lists can be controlled with the -b parameter of the mmapplypolicy command, okay, the bucket size. There's another option to control that, which is the size clause within a policy. Okay, so within the policy, you can use size clauses, which also limit the size of one bucket. It's not I mean, the size of the bucket means, the accumulated file size of all files in that bucket should not be larger than the size specified in the size clause. Okay. Okay, and now once the files have been the file lists have been created, based on the weighting parameters and based on other options, these file lists are processed, according to the rule type, right? So there are migration rules, there are deletion rules, there are list rules. I give you an example of these later on. And now the file processing happens, right? So all the files in one list are processed by one thread, right? If you work with a -m3, on each node you have 3 threads processing these lists, So the -m parameter is kind of a way to, get things more parallelized, maybe get things accelerated with the policies, and stuff like that. So the file processing is done on one or multiple nodes, and multiple threads, and the node names are determined by the -n parameter, and the number of threads per node are determined by the -m parameter. And each processing thread processes one file list. As I mentioned before, the file list has a certain number of files. These are processed. And once one thread is finished and there are more file lists to be done, another thread is launched on this node. Okay, but never more than the number specified with -m. Okay. Okay. So now you may ask yourself, so how can I program the rule? How can I tell a rule which files to select for certain things, right? So in order to understand that, you have to understand a little bit more about the file attributes, and the file attributes are specified with SQL tokens, which are predefined, and you find that in the Knowledge Center. Okay, so some file attributes, I often use are the name, which is just file name. The path name is the path and the file name. The file size is the size of the file. KB allocated is the number of blocks this file allocates on disk. Okay, so file size and KB allocated can be ambiguous. For example, if you migrated a file from disk to tape, then the file size shows the original file size. KB allocated shows 0, because the file after migration to tape doesn't consume any data on disk. Okay, so KB allocated is 0 in this case, assuming your stub size is 0. Okay. And then we have access time, we have modification time, we have change time parameters, we have file heat, which provides a measurement, which is done by Spectrum Scale, and which expresses how often this file has been accessed, read and written, within a certain period of time, and of course, as I mentioned before, ILM works on pool names. So the pool name is an important thing, to remember when you want to select files, and then there are more generic attributes like missed attributes. Missed attributes is a collection of file attribute, and the missed attribute collection for each file is represented by a string, and if you decode the string, you find, for example, the migration state of a file. You can derive from the missed attribute whether the file is migrated, pre-migrated, or resident. Okay. And then there are extended attributes, XOthers, so this is a collection of system-defined file attributes, for example, if you use Spectrum Archive and you migrate files to Spectrum Archive as an external application, there is an XOther called mmapply IBM TPS, which includes the tape name, which it gives you the name of the tape where the file is stored on. Okay. And it's always worth to look at these things, what else is, MISC-other includes all kind of things, right? You can find out whether the file is a clone, whether the file is compressed or needs to be compressed, and all these kind of things, whether the file is a symbolic link, and so on. Okay, So now I hope you got an idea how the policy engine works in the three phases. And in the next sections, I'm going to give you some examples for different types of policies. Are there any questions which are not answered or? Okay.
And it's maybe one question. It's not on the chat, but I want to ask this. The file heat, does it change when you access the data, or is it also influenced when you access the metadata?
I think it measures read and write activities on the file, Ulf, but I have to look it up in the knowledge center. But this is I think the most common thing, that it looks for how much bytes you read and write in the file,
Yeah.
There are some parameters where I can control, which period is considered and, when the file should cool down and what the pace is for the cool down, and stuff like that.
Okay. Mm. And there's just a question in the chat arriving. Which type of nodes participate in policy execution?
Which type?
Which type of nodes participate in policy execution?
Okay. So the node where you start the policy engine, like when you do the mmapplypolicy command, that is the master node. And now it depends on what you have to specify in the -n, capital N parameter of the policy engine. Okay, so if you specified node names in the -n parameter, then these nodes participate. Okay, if you haven't specified -n, then the default helper nodes are used, as helper nodes. Okay.
Okay.
It's important to know because normally I think all nodes in a cluster are default helper nodes, and sometimes it really makes sense to trim default helper nodes a little bit, to exclude some of the nodes. We should not really do this kind of stuff,
Okay, thank you. There are no other questions in the chat open, Niels, so you can proceed.
Okay, thank you. Okay, now let's briefly talk about placement. The placement rules belong to an active policy, right? Remember that. So you cannot enforce placement rules by running mmapplypolicy. Okay, so you have to activate placement rules, in the active policy for a file system. And one file system can only have one active policy. You program this active policy in a file. Okay, I'll give you an example later on. So you write this active policy in a file, and then you apply it with the change policy command. Okay, you apply this file, which includes the policy, so you apply this policy to your file system. So the placement rules are evaluated and applied when the file is created. You can only place on internal storage pools, as I mentioned before. The basic syntax for a placement policy is set pool, right? So it's a rule. You can give it a rule name, and then set pool. And here you say your pool name where it should be stored. For example, in our example, it could be system or data, right? Now you can limit the occupancy percentage of a pool. So if a pool has exceeds this occupancy percentage, I think the file is not stored in the pool. You get an error. You can replicate data, with placement policies, which assumes that you have two failure groups in your file system. If you don't have that, then it fails as well. You can limit it for a particular file set. So with this, for file set, you can align file sets to pools. Okay, if that is a matter, and then you have your SQL expression, right? If you don't, I mentioned before that Spectrum Scale instantiates active policies automatically. So if you have not specified any active policy in the file system, there's a default placement policy defined by Spectrum Scale automatically when you create the file system. And the default placement policy will place all data in system pool if you only have one pool, which is the system pool. If you have multiple pools in your file system, then the data is placed on the next pool after system pool. Okay. And I imagine somebody has the question, so which one is the next pool after the system pool, right? Well, I think it has to do with the NSD stanza file, right? When you create a file system, you provide an NSD stanza file, and the NSD with a pool name other than system, which comes first in this list, is the next pool after system pool. You know, that's at least my observation. Okay. Okay, now give you an example. So we have this setup here. You have a file system. We have 3 types of storage, right? So remember, each storage type should be in a separate pool. So we have a system pool for SSD. With our SSD drives, you know, always a good idea because system pool keeps metadata of small chunks like 4K inodes, and they enjoy low latency, you know. We have our SAS disk, you know, encapsulated in the SAS pool, and we have our SATA disk encapsulated in the SATA pool, right? The pool name here is arbitrary, right? I mean, except of system. You know, I just selected the same name for the pool like this type below, but it's arbitrary. You can use what you want. In this example, what we want to do, we want to place MP3 files in SAS pool. We want to align the archive file set to the SATA pool. Okay, so the archive file set is just a directory in the file system. Okay, and all other files should be placed in system pool. Okay, so obviously we need 3 rules. Okay, so the first rule is for our archive file set. You know, it defines that, you know, all data, you know, for files at archive file set should be stored in SATA pool. The next rule is for the MP3 files, you know, where we say all files, you know, with a name ending with MP3, you know, should be stored in the SAS pool, right? And everything else should be stored in system pool. Okay, so this clause, this default, I mean, this clause, you know, with no where statement must come last. Okay, so if you don't do that, you may end up not being able to create files in your file system. Okay, if they don't match these patterns here. Okay, and this rule, the default rule, always has to come last because the placement rules are processed from top to bottom. Okay, so the sequence of the placement rules in your policy file matters, you know. So the rule evaluation is top down. The first hit is applied, and then, you know, it's exited. The placement rule, I mean, the placement policy is exited. Okay. As mentioned, the last rule must be a default placement rule, which is catching everything else, you know. And also, you know, even though it sounds very nice to have this flexible placement thing, you know, be carefully, you know, if you have too many placement rules, like hundreds of them, you know, you slow down the file system. Just because on every file create, you know, the policy engine has to go through all your 100 rules and find the matching rule, right? And if it goes down to rule 98, you know, it takes some time for that matching, okay? So as in many cases with the policy engine, the basic recommendation is make it simple, okay? So this is a simple thing here, you know. Okay, now let's look into migration. Migration is a little bit more comprehensive because we have these active migration and these active migration policies, and we have the manual of scheduled migration policies, you know. Remember, I mentioned this before, the active migration policy are threshold based, you know. They should be simple, you know, and the scheduled migration policies are, you know, executed by a command. So this command can be executed manually, or typically it's executed by a scheduler, like in a simple case, it's cron, you know, and it can be more sophisticated, right? It can do more stuff, you know. Typically when I design policies, you know, and I usually do that in conjunction with external pools like Spectrum Protect for space management and with Spectrum Archive, okay? So with tape in the backend, you know, I make the active policy simple and functional, right? The active policy to me is a threshold-based policy and is my last line of defense, you know. I really do not want the active policy to ever hit, just because this policy hits at a time when you don't need it, right? Because it hits when your pool threshold goes when your pool utilization goes above a threshold. That can be any time. Maybe there's hard workload on your cluster, on your file system, and suddenly you hit the 80% mark on your pool, and now you do an additional tape migration. That's not nice. I mean, it's not, it's not really nice to manage. So I usually make the active policy simple and functional. And then I use scheduled policies, which run every day or maybe, every couple of hours or whatever is depends on the requirement, So I make these scheduled policies, which make sure that my pool never exceeds the high threshold, right? So the scheduled policy makes sure, that the user requirement are satisfied. For example, the user wants that all data older than 5 days should be migrated off the SAS pool, off the SSD pool, so I can have a scheduled policy which runs every day or every 8 hours, and does this, so the pool, your SSD pool never hits 80%. Of course, if the workload changes on your SSD pool, it may well hit the 80%, and then it's a good idea to monitor what's happening and figure out, okay, I get this automated migration kicked in, at times where I don't need it, and then you may have to adjust your scheduled policies, to be more efficient and prevent the active policy from being triggered. Okay. So here's an example of the active migration policy threshold-based. So it's a migration rule from pool, from your source pool. If it has a threshold with 2 numbers, the high threshold and the low threshold, and you migrate to a pool which is your destination pool. So your migrate from pool can be the SSD pool, and the to pool can be the SAS pool, right? And here you can give it a weight expression, which influences how files are sorted in these file lists and in which sequence files are being processed by the migration threads. You can limit it for file sets, and stuff like that, and add conditions here. But as I said, the active policy should be nice and functional, so don't limit it. Don't limit it, because if you limit it to one file set and you have 10 other file sets which can run full, or which can cause the file system to run full, it doesn't help. So the threshold statement defines the threshold at which the rule is triggered. Okay, the rule is triggered automatically by GPFS. Okay, so the high threshold, this is the high threshold for your pool, and the low is the low threshold for your pool. And you encode this policy into a policy file, or you encode these rules into a policy file, and you activate it for the entire file system. Okay, so this causes when this threshold you specified with high is reached on your pool, then GPFS will trigger an event. Okay, this event needs to be processed by a callback, which eventually invokes the policy engine with the mmapplypolicy command. Okay, so you need a callback, you need to configure a callback, and the callback essentially, invokes the policy engine when the threshold is met. Okay, so as I mentioned before, when the pool crosses the threshold, you have encoded in your active migration threshold-based policy. Spectrum Scale throws events. The relevant event for this are the load this space event and the node this space event. Okay, so whenever a pool crosses, a threshold which is given in an active policy, GPFS triggers one of these 2 events. Okay, so we need a callback which catches these events and calls our mmapplypolicy, our policy engine. Okay, so the callback essentially, executes a customizable script with selective parameters. So As a default script for the callback, which is provided with Spectrum Scale, it's the mmapplypolicy command. It's a script. You can modify it if required, But if you look at mmapplypolicy, it actually invokes mmapplypolicy, okay? To configure the callback, you use the mmapplycallback command. You say the callback should run this command, like the mmapplypolicy command. It should be catching the events, load this space and node this space, and it should pass the parameters event name and file system name to that mmapplypolicy script. Okay, and once you configure this callback, and your file system pool runs across the threshold, the load this space event will be triggered, and the callback will execute this script. Okay, and this is done on the file system manager. Okay, you may know that the file system manager is not fixed for a given file system. It may change, but this script is always executed on the file system manager. Okay. And also in the file system manager log file, you find that a migration callback has been triggered. During some health checks, I typically check the manager log files, and I always see that policies are triggered in the middle of snapshot deletions, in the middle of high workload, and stuff like that. These are always good findings, but it's based on the fact, that your active policies kick in at a time when you don't need it, so you should use scheduled policies, to be more proactive, handling the migration of your data and handling the life cycle of your data. Okay, now last but not least, let me give you an example. So we have a file system with a system and silver pool. Okay, all files, the active policy should migrate files when the system pool is 90% utilized, and it should migrate all this file first. Okay, the placement should be that the MP3 files are stored in silver, all other files are stored in system. Okay, so we need a couple of rules. Okay, so the first rule is our migration rule, which migrates from system to silver if it hits 90%. So the rule looks like this, we migrate from pool system at threshold 90 down below 70. So 70 is the low threshold. So the migration job, which is started if the pool hits 90%, will actually try to migrate as many files until it reaches 70% pool utilization. And that is decided during phase 2, when the files are chosen for migration. So, because in phase 1, we get a whole list of files, but we may only need to migrate 30% of them, or 20% of them, in order to reach 70%. So the choosing is done in the second phase of the policy engine run. Okay, so 90 is our high threshold. We give it a weight because we want to migrate the oldest file first. So we subtract the current timestamp from the access time stamp. And the weight always resolves to an integer value, and the files with the highest integer value are preferred, or migrated in this case, or processed first. Okay. And of course, to pool silver. As you see, there's no where clause. I don't need a where clause. What should I put in as a where clause, right? I mean, because the where clause can always be wrong. It's always a point in time snapshot where you say now today you want to migrate all PDF files. Tomorrow it may be PDF doc files, or ISO files or whatever, right? So forget the where. I usually do not like to use where on an active policy. There are exceptions, but by default, I don't use it. Now, this is our migration policy, which does the job here, right? Then we have two placement policies. So we have a placement policy for the MP3 file should be placed on silver. Okay, so this rule, set pool server, var loan, pass name, and all the other files should be placed in system. So this is our default rule. Okay. Now we put these 3 rules into a policy file, and we activate it with the change policy command for our file system. Okay. And then it's active. Okay. And then if your system pool reaches 90%, then the files are automatically being migrated off the server. Okay. But as I said, there may be a better way to manage the migration using scheduled policies. Okay. So with scheduled policies, you do not have to use thresholds. You can use threshold, but I usually don't use threshold unless there's a reason for that. So again, it's a migrate policy from pool to pool. You can work with state expressions here as well, to influence the sorting of your files, to get oldest files first or largest file first, and you migrate to pool. And typically you have a where clause, right? So the where clause, describes, the file to be selected for migration. It's based on file attributes, as I've shown you before. It can be for file set, it can be files with a certain access age, or exceeding a certain access age, or files, from a certain owner, and so on. Okay. And this policy is executed with the mmapplypolicy command. Okay. Now let's put in a policy here to avoid system from flowing over or from reaching 90%, and say all files which are not accessed for 30 days should automatically be migrated to the server pool. Okay, so the associated rule is this one. We migrate from pool system to pool server. Of course, where the gap between current time and access timestamp is greater than 30 days. Okay, now we put this in a file, this rule, and we run it with mmapplypolicy. And if it works correctly, we schedule that command via cron, so it runs every day. Okay. And this hopefully makes sure that system pool never reaches 90% because the oldest files are being migrated to the server pool. Okay. And again, for further tuning, of your policy, you can specify nodes, which should carry out the policy, and you can specify the number of threads and the bucket sizes and stuff like that, Okay. So, any questions? Well, if not, let me continue. List policies. I mean, list policies are very, I love using list policies, because you can get so much insight from your files and your file system and your data, or data types, which is amazing. Okay. So list rules allow identifying files based on file attributes. Okay. We have learned that before, that's what the policy engine does, right? It matches files to file, it matches the files to certain rules, it selects these files, but the policy engine does this by loading the inodes, into memory, instead of calling the file system, because calling the file system can get really slow in GPFS, because usually you have a lot of files in your GPFS file system. Okay. So the list policy syntax is, well, I mean, in the correct way, it's two rules. In the first rule, you define your external list. The purpose of an external list is to specify a program, which can process the files which are selected by the second rule. And the second rule actually, is the list rule. It refers to your external list rule by this naming here. And here you specify the conditions. Okay. To execute this list rule, you use the mmapplypolicy command, for your file system scope. I mean, it can be the file system path, the file system name. It can be a file set name within the file. It can be a path into a file set, in your file system, or it can be a path into any directory into your file system. Depends on why you want to do this listing, right? And what you want to list, The important new parameters here are -f, which allows you to provide a file prefix, and -i defer. Okay, so -i defer, essentially finishes after the second phase. Okay, so it just does the selection and the choosing of the files, but it doesn't do any file operation. Okay, that's what the for does. Okay. Now, if you have a list policy and you run it this way, it will store an output file in your file prefix which has the name of file prefix. This is this name you give here, right? It doesn't have to be file prefix. It's just a token I put in, and then the fixed token is list, and here this token is list name, which is the name of your external list rule. Okay, so it's this name. Okay. And when you run it, when you run a normal policy, with this, the output you see here looks a little bit strange like this, where, this is your inode number, this is the inode generation number, this is the snapshot, the snap ID. This is kind of a separator, and that actually is your file name, your parsing file name, which has been selected by the policy. Okay. And, so this way you can see the files which have been selected which match these criteria. Okay. So let me give you an example. Let's create a list of all non-resident files and include the tape ID, in Spectrum Archive with the file. So we assume to have a with an internal pool and an external pool. The external pool is managed by Spectrum Archive. Okay. So, I mean, one thing we do, we define a macro. A macro really is provides a name, an easy to read name, along with a condition. The condition is this one. See, we look for a MISC attribute. Which is not like -m, and this denotes resident files essentially, right? We use this macro later on in our policy here, and now we define our two list rules. One is the external list. We call it tape ID. We don't specify a external program to process that list yet. So we just end it here, and then we have another rule. Which has two interesting things. One thing is it shows us an XORDER. Remember the XORDER, right? And it shows us this value, the DMAPI IBM TPS, which should include the tape name. Okay. And of course, only files which are not resident will have a tape name associated with it, because resident files are not migrated. Okay. And are not on a tape. Okay. So if you put these three lines into a policy, and we run this policy for file system, with this policy file name, we store it in /tmp.mia, and run it as the for. We get a file list like this, in /tmp and in /tmp with this file name here, list is a list policy, tape ID. Tape ID comes from here, right? And the file now looks like this, right? This is our inode number. This is our inode generation number. This is our tape ID. And here comes this adder, okay? So this attribute is, 1, and SLE33 L6 is a tape ID. L6 stands for LTO6, so it's really all tape, and it tells us which file it is, right? And of course, it would not only contain one line in a managed files, in the space managed file system. It would contain many lines, which allows you to understand on which tapes your files are stored. Okay. Okay. So I mean, this policy also results from a practical example. Okay. Now, last but not least, a few hints and tips. I have already shown you the macros. I really love using macros because they make my policy or my rule much easier to use. Okay, so the syntax for macro is define, and then the macro name and the condition. Okay, and what happens here is really, the macro name, you use the macro name when you write the policy, but when the policy is executed, you actually see that statement in your policy. Okay, so the policy engine expands the access age to your condition and expression you have specified here. Okay, so access age is one macro, because typing all the time days current timestamp minus days access time, it's exhausting, right? So I love using macros. The same with these kind of attributes like, is migrated. We have looked at is resident before. Now this is migrated, right? You can also, because many, like for example, file size is reported in bytes, KB allocated, of course, in kilobytes. So you can translate that into GB allocated, like gigabyte allocated, for example, right? You can have a macro, which identifies immutable files, or which places a condition on immutable files, or you can have macros, which tell you, which you can use to see if files are replicated or not, right? Replicated if you have file system replication, and you want to check that all files are being replicated on both sides, you can, write a list policy for that. And of course, you could use this macro, right? If you want to use this macro with this policy, no, you cannot use it with this policy. You would use a list policy. So you would have to insert a list policy. Okay. So another tip here is exclude rules instead of exclude macros. I think exclude rules have been introduced later, so many admins which use GPFS for a long time, they are still in use using macros for exclude lists, but the exclude rules are much more efficient. Exclude rules only work for migration and deletion and not placement and not list policies, okay? So the key tokens or the key expressions for macro are the exclude. It's an exclude rule, Of course, you can go for file set, and then you do a where with an SQL expression, right? In a policy, in a migration policy, when you want to exclude something, the exclude rule has to come first, okay? And what happens is, when the policy engine starts, it first matches all the files against the exclude rule. And all files which match the exclude rules are excluded from all other subsequent rules. Okay, so that's much more efficient, because you don't carry on all the files in your file system into the other rules, into the subsequent rules. Okay, so for that reason, exclude rules are much more efficient than using exclude macros in a where clause, And here's an example for an exclude rule, typical for tape migration, where you have a .spaceman directory from the space manager, so you want to exclude everything from .spaceman. Of course, you want to exclude everything from .snapshot. You wouldn't be able to migrate it anyway. It would throw you lots of errors, And of course, if you do MM backup, you want to exclude the MM backup shadow database because it's required for the next backup cycle. You don't want to migrate that as well. Okay, so in this way, if you run a migration for your file system, then all files matching these expressions here, like the path names, and the file names, all these files would be excluded for all subsequent rules, Another interesting thing I use is string substitution in a policy. Okay, so essentially what you can do, you can substitute a string in a rule by providing the appropriate parameter via the mmapplypolicy command. Okay, so one example is, you want to migrate based on file set names. Okay, so you have learned before, for the migration rule, we have a for file set class, where we can specify one or more file set names. Okay, So instead of specifying a real name of a file set, I just give it a token here, which is file set name. Okay, and then when I invoke this policy here, when I execute this policy here with the mmapplypolicy command, I have my mmapplypolicy command, and to substitute a string, I use the -M parameter, and here's my file set name token, and here's the value, which is being replaced here. Okay, so when you execute this policy, you will see, that the file set name here, or the file set here, is no longer file set name, but it resolves to test if your file set is called test. Okay, and of course you can replace other parameters as well, right? So for example, if you want to migrate based on file sets but different access ages, you need one policy. You need one policy, where you replace the file set name and you replace this number here, with a string substitution. Okay, as simple as this. Yeah, with the wait clause, as you've seen, you have it in all kind of policies, migration, list policies, and so on. So the wait clause allows you to sort files, which are then provided for the file execution, or for the file processing. The wait usually translates into a integer value, and the files with the largest integer value are preferred, okay, or put on top of the list. Okay, the default wait parameter is KB allocated. Okay. So now there are different ways to use wait clause more efficiently. You can sort files by their usage age with the oldest file first. Okay, so your wait statement would be the access age macro, essentially, as I have shown you before. Okay. Another example, which I had actually implemented was, that the migration should prefer files from certain directories first. Okay, now imagine you have a file system with two file sets, and from one file set you don't really want to migrate, only if it's really necessary, and that most of the data goes into into another file set, so you can define the wait based on the path name, right? So everything going in your path directory, dir1, gets a weight of 4, So all files, matching the path name dir1 have a number 4, and all files, having a path name dir2 have a number 3, So when the policy engine kicks in, it selects all the files, which are subject for this migration here, right? We have no where statement, so it selects all the files which are not migrated, for example, right? In the first phase. In the second phase now, it will sort the files based on their weight. And this means all the files, from dir1 are on top of the list, okay? Now, if this policy would have a threshold, okay, a low threshold, a high threshold, and low threshold, then, maybe the files in directory 1 already satisfy, the low threshold. Okay, and this way, files in directory 2 would not be migrated. Okay, so, I mean, there are all kinds of things you can do with wait statements. I mean, really nice thing, also working with case, and stuff like that. Okay, so last thing on the hints and tips section, is using input files to the policy engine. So instead of having the policy engine load all the inodes from your file system, you can tell the policy engine, in particular, which files it should look at and match it against the rules. Okay, this eliminates the need for the file system for the policy engine to scan the file system. Okay, So the input file you provide to the policy engine must include the fully qualified path or directory names. Okay. So for directory, it's going to be this syntax. For file, it's going to be this syntax. And to pass this list into the policy engine, you use the -I input file parameter. Okay. I mean, one example is, you want to list all files with the extended attribute user backup set to yes, and you have already a list of files available from a previous run. Okay. Then you can put all these files into the input file and send it to the policy engine. And the policy engine would only load the idle information from the files provided in this input file and check whether the extended attribute user.backup, which is a user space attribute, has been set to yes. Okay. So this is one example where I implemented this kind of thing, to avoid, running through the entire file system again, because I already had a list of files, which I wanted to check, So instead of having the policy engine, run through the entire file system and check the files again, I provided the list of files I had already. Okay, I could probably go on for another hour, with that, I'm really glad you were bearing in with me. Here's some key references. There's a white paper, which is the quick start guide for the Information Lifecycle Management policies in GPFS. So if you really want to learn more about it, have a look at this white paper. I have a GitHub. We have a GitHub repository, with policy samples and policy scripts, So if you want to learn more about that, have a look into that GitHub repository. And of course, a valuable resource is always the Knowledge Center, right? I always have to look at the Knowledge Center. I mean, I know by heart by now, where the information lifecycle stuff is and how it's structured, right? So it takes me 2 seconds to get there in the Knowledge Center, So you, as a policy guy, you really have to know where the section is, and here you find all the information you need. Okay. Ulf, are there more questions, or add something?
Yeah, I have received one question in advance, so I will type this in the chat right now. I cannot post to the Q&A chat, so are there any limitations or recommendations around lengths of rules in policy files? For example, we have 750 file sets. We want to place data on a specific pool. Should we just have one rule or many rules?
Well, this would mean, the placement policy is one policy file anyway, but 750 placement rules doesn't sound too good, I would probably try to structure it in a different way, because you probably don't have 75 or 750, was it 750? You probably don't have 750 pools, right? So I would probably sort the placement policy by pools. You can have a maximum of 8 internal pools, so you should end up with 8 placement rules. Use the 4 file set statement. And in the 4 file set statement, you can specify the file set names. You can specify multiple file set names.
Okay. And then there was one question in the Q&A chat. So can I identify the type of the file with the policy engine via the magic byte? And Wayne already has answered that is not possible. Yeah, we can only access the metadata, but including the extended attributes, but not the data itself. Yeah, and maybe a different approach to solve this would be to use file audit logging. Yeah, when you want to do it in real time, and then have some script to trigger a script to read this magic byte and store it in an extended attribute. And after that, you could apply it or read it in policies. Yeah, would that be a feasible approach, or what do you think about this?
You mean like watchful, right?
Yeah.
File auto logging. Yeah.
Yes.
Yeah. Well, I mean, this could be an approach. You have to get familiar with watch folders. One other thing could be, that you use list policies. So I mean, you essentially use list policies with your own program. So the list policy will list all the files which you need to know the file type from, right? I mean, it can be a certain file system scope or a file set scope or whatever, and then you have your external program, your external script, which does a file on each file and puts that string into the extended attribute, right?
Okay, sounds good.
Yeah, but I mean, it's a similar approach like with watch folder, right? With watch folder, you can intercept the open of the file and do your own stuff, right? So you can check what the type of the file is by doing a file on the file example, for example, right? The other question really is, what tool are you using to identify the type of the file? I mean, the simplest approach in Unix is to use the file command, right? But the file command is, I mean, it's limited, right? I mean, it probably cannot determine whether you have an NCF file or something. You cannot differentiate an NCF file from another container format. But in any case, I mean, with both approaches, you can run your own tool, which determines the file type. That's what we don't have in the policy engine, right? We don't have a tool which determines the file type. We only go for the metadata, as you said.
There are open source tools. Apache Tika is designed exactly to do this. You can run that and then save the results from Tika into an extended attribute.
Okay. Yeah. Well, I mean, this brings up some other solution with Spectrum Discover, right? I mean, you could integrate Spectrum Discover with Spectrum Scale, and then store these attributes in Spectrum Discover.
Yes, and that brings in the full Watson Studio, so you can run scripts on the data and extract all sorts of information about the semantics.
Yes, it's a great idea. I like that. Wait.
Yeah. So, Niels, if you look at the chat, there was a comment by Mark. Do you want to respond to this one?
Okay.
But you would need to store and reset A time when using external program.
I'm not sure what the question is. If you're using A time in a policy, then yes. If you're using file heat, then only A time change, then it won't change file heat.
So we are only a few people. So I will try to unmute everybody, and then Mark can ask us the question directly. Mark, can you try to explain your question?
Hi. It wasn't really a question. It was a statement when people were suggesting to use an external program to go and look at the magic byte to get the file information. The problem with doing an external program would change the A time of the file, which obviously if you're storing A times and doing statistics, you need to store the A time, do what you need to do, and then reset the A time of the file back to what it was.
Yes.
That's true.
But in this case, Wayne, I'll go and look at Tika because I've not heard of that. So thank you.
It's very powerful. I'm surprised it's not more popular.
Okay. And I think that are all the questions that I have seen.
Alrighty. So with this, I give back to Bob.
All right. Thanks, Nils. That was a great overview. Actually, even though I've been working with policy for a while, I did pick up some new tips and techniques. So, so great. So that's going to wrap it up for today. And I want to remind everybody that to check out, look for the charts and everything showing up on spectrumscale.org/expert talks. And our next talk on AI workloads is going to be on Wednesday, November 4th. So look for announcements and details on that upcoming. And that will wrap it up for today. Thanks again.